2017. I'd like to work on the part 1 right now, and then I can do the part 2, 3, 4s later. It says, which expression is equivalent to 16x squared minus 36? We've talked about ways to check for equivalency in previous lessons, but for right now I'm going to continue to use tables because I want to do things based on what we already know how to do. So if I go to the table option, graphing option first, I'm going to type in my original, and then I'm going to type in each of my choices. There's choice 1. Choice 2 has a plus 3. Oops. 2x minus 3. Okay, I'm going to go back up there and make sure I've got that last parenthesis. 4x minus 6. And 4x minus 6 again. And then 4x plus 6. 4x plus 6 again. Alright, if we go and look at the table of values, in order for something to be equivalent, it would have to have the same table. So again, just to keep a little code here, the very first one is in blue, the second one is in red, then black, then pink, and I believe the last one is green. So when do I see negative 36 again? I don't see it in the red. I do see it in the black. I don't see it in the pink. And I don't see it in the green. So the only one that has the negative 36 is the one that's in the black. Just to be sure, do they match all the way down? If you focus on the blue and the black all the way, they do in fact match, therefore they are equivalent. What is the solution set of the equation? Okay, solution set, this is what I'm going to store. So practicing the storing option. I'm going to start with negative 2. Negative 2 store into x. Okay. And I don't know what a is, but I'm going to pick a number. I'm going to see if this actually works. You know what, actually I'm not going to do it this way. I'm going to do this the right way. So let's go down to number 2 and I'll show you how to work it out. Alright, so we have x minus 2 and x minus a equaling 0. And there's something to keep in mind. You can only have 0 be the answer in a multiplication problem if either the first thing is 0 or the second thing is 0. Like I can't get 0 if I multiply 5 and 7, but I can get 0 if I multiply 5 and 0. Or I can get 0 if I multiply 0 and 7. So in order for this to be true and it to come out to be 0, either this part has to be 0 or the second part has to be 0. Now in order to solve these, I'm going to add 2 to both sides. That means that 2 is one of my answers. I'm going to add a to both sides. I should have shown that step, I apologize. So 2 and a are the 2 answers. Choice 3. Analysis of data from a statistical study shows a linear relationship in the data with a correlation coefficient of negative 0.524. We haven't talked about statistics yet, that's at the end of the semester, but a couple things to keep in mind. Which statement best summarized? If it's negative, then we know that it's going to be a negative correlation. Therefore, anything that says positive, I'm going to eliminate. And because it's 0.5, this is from a scale of the numbers themselves. Ignore the sign. The numbers themselves fall between 0 and 1. 0.5 is somewhere right in the middle. Would you consider that strong or moderate? And I would consider it moderate. It's right in the middle. Choice 4. Boyle's law involves pressure. We're given a formula. And we want to solve for P2. So I'm going to show this on the paper. You can hear my son bouncing around in the background. Alright. I'm trying to solve for P2, which means I'm trying to get P2 by itself, and right now P2 and V2 are multiplied. When you have two things next to each other and there's no plus sign, no minus sign, and no division sign, multiplication is the only thing left. So if I want P2 by itself, I have to get rid of V sub 2. And just like that, I'm done. Look at your choices right there. Choice 3. A radio station did a survey to determine what kind of music to play, taking a sample of middle school, high school, and college students. They were asked which of these different types of music they prefer on the radio: hip-hop, alternative, or classic rock. The results are summarized in the table below. It says what percentage. When you're talking about percentage, you're talking about part over whole. So what percentage of college students prefer classic rock? So here's the college students. Okay, the total group that we're pulling from are college students. That's your whole, and that's 16, 20 makes 36, plus 14 makes a total of 50. Now, how many of them are classic rock? That's going to be 14 out of 50. You throw that in the calculator, and that's going to be 0.28. Well, we haven't talked about it yet, but 0.28 represents 28%. Which of the function has zeros at -4 and 2? We talked about this already. Zeros are another way to say roots or x-intercepts. So I'm going to check my pictures first because that seems to be the clearest. Number 4, 1, 2, 3, 4, has a -4 root and a +2 root. -4, +2. I'm not going to check the others because only one of them should have had an answer of -4 and 2. Okay, we're back to equivalency, and there's only one type of variable in this question, so I'm going to do this the same way I did question number 1. Again, there's a lot of math that we haven't covered in our curriculum yet, so I'm just trying to give you what we've learned so far and how to get by with that information. So I'm going to go up to y equals, and in the black I'm going to type the original, 2 times 3. In this case I'm going to use x because I'm on a graphing screen, minus parenthesis 8x plus 3. So this is the same expression except with x is substituted. I'm going to put in red choice 1, -2x minus 1. In choice 2 I'm going to put -2x minus 5. In choice 3, I'm going to put -2x minus 7. And in choice 4, I'm going to put -2x minus 11. If they're equivalent, they should have the same tables. So blue does not match red, black, or pink. Does it match the green? Well, let's double check a couple numbers here. -11, -13, -15, -11, -13, -15. So the last row and the first row do match. Therefore, that one is equivalent to the original. And I'm able to check that without actually showing any math. Moving on, just trucking through. It says in 2014, the cost to mail a letter was 49 cents for up to 1 ounce. Every additional ounce was 21 cents. Which recursive function could be used to determine the cost? So before we begin, a recursive function can be found by first identifying the very first number in the sequence. A1 is the first number in the sequence. If it didn't say A1, you would eliminate that question right away. So the first ounce is 49 cents. That means A1 should be 49. I don't have to go any further. I'm able to figure out everything else from there. Okay, now does this make sense? This formula says, okay, after your first ounce, you're going to add 21 every time. Additional ounce, 21 every time. So that makes sense. Next one. A car leaves Albany and travels west toward Buffalo The equation is d equals 280 minus 59t, can be used to represent the distance from Buffalo after t hours. And this equation 59 represents. So 59 is attached to the variable, which means that it's represented as the slope in this linear equation. It's the word that would be attached, or it's the number that would be attached to a phrase having the word per in it. So would distance have per attached to it? Would speed have per in it? Distance, number of hours driving. My first thought, speed. Miles per hour. But more so, does that make sense? Does 59 seem like a typical miles per hour that you would drive from Albany to Buffalo? And the answer is yes, that does make sense. Now the reason it's minus is because when you multiply miles per hour times hour, the hours cancel. So what you're saying is your distance, your miles, is decreasing from the full 280. You're getting closer. So again, that makes sense when all is said and done. Number 10, Faith wants to use the formula, and it's given to convert Fahrenheit to Celsius. If Faith calculated C of 68, what would the result be? So 68 is in the parentheses, which means 68 is the F. I'm going to type this in the calculator and let it do its magic. So here we go. 5/9 followed by parentheses 68, whoops, minus 32. That comes out to be 20. 20 is the C value. So first of all, I would get rid of anything that didn't say 20, and then I would be mindful of the answer. The output is the C, so 20 degrees Celsius. Which scenario represents exponential growth? We haven't talked about exponential growth yet, but it is a graph that looks something like this. It is growing faster. It gets steeper and steeper as we go on, and it tapers off if we're coming from the left side here. Now, if it's a consistent thing that's changing the same amount every single time, like you know, if you're getting paid an allowance of $10 per week, that's not changing. But if your pay is being doubled, let's say you're getting $10 this week, $20 next week, $40 the week after that, that's an example of exponential growth. It's not the same consistent amount, but the amount is changing regularly. So look at these and which one represents changing. A water tank is filled at a rate of 2 gallons per minute. Well, no, 10 minutes down the road, it's still filling 2 gallons per minute. A vine grows 6 inches every week. Well, 10 weeks from now, it's still going to be growing 6 inches every week. And it says a species of fly doubles its population. Would you agree that its population now, how it's changing from maybe 10 flies to 25 flies, will be significantly different than when it changes from 20 to 40 or 40 to 80? And the key word there is double. Double is an example of an exponential growth here. Okay. What is the minimum value? Minimum. We already talked about minimum being the lowest y value. You may not be familiar with these vertical lines though. This represents the absolute value. If on the Regents exam you're not sure what something is, you can always find it, or where something is, you can always find it in the catalog, which is in blue above the 0, so it's catalog. So if I go to y equals, because I want to see where the lowest number is, here these are. I'm going to type in the absolute value. Again, I don't know where it is, so I would go to catalog, and it's the very first thing written, abs. You'll see the vertical line's already created for you. Put x plus 3 inside the absolute value symbol, and minus 2 on the outside. When you look at the graph, you can see that it's a V that pops down to this point. That point is the lowest point. That point is at 1, 2, 3, -3, -2. Just to be sure, I'm going to look at the table, and at -3, the answer is -2. Minimum value represents the output though. What's the lowest output? And the answer would be -2. Choice 1. What type of relationship exists between the number of pages printed on a printer and the amount of ink used by that printer? Well, let's use this in a sentence. If I print more pages, then I would expect to use more ink. So as one increases, the other one does as well. That's a positive correlation. Now, is it causal? Does printing more pages cause me to use more ink? And the answer is yes, this is causal. There's other things that are positive correlation, but they don't necessarily go together. For example, as my height increases, my foot size probably increases as well, but it doesn't mean my height causes my feet to grow. A computer application generates a sequence of musical notes using the function f of n equals 6 times 16 to the n, where n is the number of the note in the sequence and f of n is the note frequency in hertz. Which function will generate the same note frequency as f of n? This is just a fancy way of saying which one is equivalent. See how it says same here? And we already know that when we're talking about equivalency, the easiest way to answer that is to go to y equals, type in your original. Again, I'm not going to type in n on this screen, I only use x's on this screen. And I'm going to type in all of my choices. 12, parenthesis 2 to the x, 4x, followed by 6, parenthesis 2 to the 4x, followed by 12, parenthesis 4 to the 2x, and finally 6 times 8 up to the 2x. And I want to know which one is equivalent to the original. I see 0.00146. I do not see that in the red, which was choice 1. I do see it in the black. So again, you might want some color coordinated symbols here on the next to these questions. Sorry. The pink does not have 0.0041 or 146. It does the green. And the green does not either. So by process of elimination, I'm going with choice 2. Alright, keep going. What's the solution? Okay, so if you're talking about solution, then each of these numbers is a potential answer, which means if I don't know how to solve this question, what I can do is store the number that I see, in this case 36 over 25, I'm going to store it into x, and then I'm going to test to see if it works. 13 minus 36x squared equal to negative 12. Calculator says no. Gone. Okay, well what about the other fraction? 25 over 36. Store that into x and then check. Calculator says no. What about the fraction negative 6 over 5? Calculator says no. So I'm hoping the last one does in fact work. Again, there's other ways to show this, but with the limited amount of curriculum we've learned so far, this process works even without knowing how to solve it appropriately. So the answer is 4. Which point is a solution to the system? Okay, so in order to be a solution to the system, which means 2 or more of these existing, it's got to be true for both. Every single one of these points is a list of an x and a y value. So I'm going to do the same thing I did for 15, except I'm going to store into x, and I'm going to store into y. And then I'm going to check both of these to see if they work. Starting with 2y less than negative 12x plus 4. Okay, it didn't work in the first one, so it's automatically not a solution. It's got to work for both. Alright, 0 stored into x, 6 stored into y. Let me check the first inequality. It does not work, therefore it can't be a solution because it's not a solution to both. Next point. Oops, negative 1/2 stored into x, and 5 stored into y. First inequality. It does not work, therefore it's not an answer. Last point. Store that into x. Store 2 into y. Check the first inequality. And it does work, but let's check both inequalities because it's only a solution if it works for both. There you go, it worked for both. And just like that, we're getting close to the end here. When the function f of x equals x squared is multiplied by the value of a where a is greater than 1, the new function, the graph of the new function, well, let's see here. If I start with a blue graph of x squared, and then I put a number in front and that number is greater than 1, so maybe 5, then I want to describe the blue graph and the red graph and what's happening. So the blue graph is a standard parabola. The red graph is also a standard parabola, but it's much thinner. It appears thinner. So it appears narrower, which means it's got to be choice 2 or 4. Does it open up or down? Well, that's still opening up. It's as if it's reaching for the sky, right? That's an open up. If it was negative, it would open downward. Andy has $310 in his account. Each week he withdraws $30 for his expenses, which expression could be used if you wanted to find out how much money he had left after 8 weeks. He starts with 310. This is otherwise known as the y-intercept in our linear equation. So 310 would be our initial amount. I'm seeing 310 only show up here, so I'm going to go with this for a second. Each week he withdraws $30 for his expenses. Which expression could be used if you wanted to find out how much money he had left after 8 weeks? Okay, so let's see what's happening here. What I would do probably, I think the easiest way to do this problem is actually think about some of the money. He starts with 310 and he's withdrawing $30 a week for 8 weeks. So if I withdraw 30, that next number would be 280, followed by 250, followed by 220, followed by 190, 160, 2, 3, 4, 5, 6, 130, 100, 1, 2, 3, 4, 5, 6, 7, 8. So I want these numbers to show up. All I'm going to do is type in all of my answers and see which one gives me a table that looks like the one I just created. Starting with 310 minus 8x. Remember, I'm on the screen, so I'm using x. 280 plus 30, x minus 1. 310x minus 30. And 280 minus 30, x minus 1. All right, look at our tables and look for 310 starting at 0, because that's the beginning of this. 310 is in the blue, which would be choice 1 here. So we're going blue, red, black, pink. It looks like choice 1, let's get this all at 0, hold on. There, let's start at the beginning again. Blue and pink start with 310. So I'm going to eliminate choice 2 and 3. However, pink is the only one that has the 280, the 250, the 220, the 190, 160, and so on. So it's got to be choice 4. The daily cost of production in a factory is calculated using this model, where x is the number of complete products manufactured. X is the number of complete products manufactured. When it says domain, they want to know, okay, what numbers make sense for x? So can you have integers? Well, integers are both positive and negative whole numbers. Can we have negative numbers representing the number of complete products? No. Positive real numbers include weird numbers, irrational numbers like pi. Can you have pi, number of completed products? Nobody says that you created pi products, so get rid of that. Positive rational numbers. A rational number would be like 1/2, you know, things that can be written as fractions. Can you have a complete half a product? No. But whole numbers start at 0 and count up 1, 2, 3, 4, and so on. Does that make sense for the completed number of products? And that would be yes. 20. Noah conducted a survey on sports participation. He created following 2 dot plots to represent the number of students participating by age in soccer and basketball. Which statement about the given data sets is correct? The data for soccer players are skewed right. Skewed right means pulled to the right. Okay, well, soccer players is right here. Does that look like it's pulled in any direction, or does it look like they're kind of random? And that, in fact, is random, so that's not true. The data for soccer players have less spread than the data for basketball players. Okay, the spread is 3 in either direction. This one's 3 in either direction, but because we're not familiar with spread yet, let's wait on that. The data for basketball players has the same median as the data for soccer players. Median is middle number. So if there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 different players, you're looking for the 9th number. 1, 2, 3, 4, 5, 6, 7, 8, 9 would be in this category. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 players. 1, 2, 3, 4, 5, 6, 7, 8, 9 would be in the 10 category. So they are not the same median. The data is a greater mean, and greater mean than data for the soccer players, basketball. So mean is the average. Okay. If there are 18 people, in order to find average, you add up what you know and divide by what number there are. So in this case, I have 3 6s. I'm going to shorten this up by just writing 3 times 6. I have 4 7s. I have 2 8s. I have 2 9s. I have 3 10s. I have 2 11s. And I have 2 12s. If I divide that number by 18, then my mean for soccer players is 8.6 repeating. If I do the same thing for basketball players, I'm going to go back to that statement that I had up here, and I'm just going to change my coefficients. I have 4 12s, 4 11s, 3 10s, 3 9s, 2 8s, 1 7, and 1 6. Take that number, divide by 18, and my mean for basketball players is 9.8 repeating. So let's read that statement. Is the mean for basketball players greater than the other one? And that's definitely true. Choice 4. Almost done. A graph of average resting heart rates is shown. Average resting heart rate for adults is 72 beats per minute, but doctors consider resting rates from 60 to 100 beats per minute within normal range. Okay, between 60 and 100 is normal. Which statement about average resting heart rates is not supported? A 10-year-old has the same average resting heart rate as a 20-year-old. Okay, so here's a 10-year-old. Here's a 20-year-old. Those numbers are not the same. So which statement about average resting heart rates is not supported? That one is definitely not supported, but let's double check that the rest of them are supported. A 20-year-old has the same average heart rate as a 30-year-old. Okay, so that's supported. 40, same rate for 10 years, has the same average resting rate for 10 years. So here's a 40-year-old, 10 years in either direction still does match. Average resting heart rate for teenagers, which would be below 20, steadily decreases. Well, that is true. Before we get to 20, it is going down. So 10 and 20-year-olds do not have the same resting heart rate. Just a couple more. The method of completing the square was used to solve the equation 2x squared minus 12x, Which equation is a correct step when using the method? So another way to interpret this is which one is going to be equivalent. They're all written as if they were completed using completing the square. But just in case you didn't know what that is, and we're not going to see that for quite a bit, here's another way to answer the question. The original has equals 0, so I want all of these to equal 0. That means I have to subtract 6 from both sides, or add 6 to both sides, or subtract 3 from both sides, or add 3 to both sides. And what that does is it gets rid of the right side of the equation, but do not put that in the parentheses. This is going to read x minus 3 quantity squared minus 6 afterwards. So again, I'm going to check my colors here. I'm going to go into y equals, clear out the original, write the original 2x squared minus 12x plus 6. Then I'm going to write in all of my choices. Choice 1 is quantity x minus 3 squared minus 6. Notice the minus 6 on the outside. The next one is x minus 3 quantity squared plus 6. Notice the plus 6 on the outside of the parentheses. Followed by x minus 3 quantity squared minus 3 on the outside. And last, x minus 3 quantity squared plus 3. If you look at your table of values, which one is equivalent to the original? The original says 6, negative 4, negative 10. And I don't see 6, negative 4, negative 10 on any of the next choices, but is it in the last choice? It is not. Okay, so let's see here. What did we do wrong? Which equation is a correct step in using this method? So, here's what I'm going to draw your attention to. Okay, so not equivalent, but let me show you a quick lesson on completing the square. Completing the square takes the original quadratic equation and it gets rid of this first coefficient. So that's a 2. That means I'm going to divide everything by 2. I can divide it all the way out, but since it's divisible all the way through, let's do that. Let's divide everything by 2. That's still equivalent to the original statement. Okay? Now what I'm going to do is change. I'm going to come back to this to show you the right way, but I'm going to change what I typed in originally to say x squared minus 6x and then plus 3. And look at the tables. Now you can see that the blue and the red actually match. Double check that the green doesn't. No, green still doesn't. So I'm assuming that red is going to be the answer, choice 1. But just to be sure, here's how completing the square works. You take the middle number, divide it by 2, and square it. Negative 3 squared is 9. That means that I need this number to be a 9, not a 3. Let's bring the 3 to the other side. If it goes to the other side, it becomes a negative, right? Add 9 here, add 9 here. This now number on the right side is going to be positive 6, and this simplifies to x minus 3 squared, and that is choice 1. Last 2 questions. Nancy works for a company that offers 2 types of savings plans. Plan A is represented in the graph below. Plan B is represented by this function, where x is the number of weeks. Nancy wants to have the highest savings possible a year. Nancy picks Plan B. Her decision is correct or incorrect. Okay, so what I would like to do is have this picture on this graph so I can actually compare the 2 better. And the only way to do that well is to have a graph of it. Again, clear out the calculator here. Alright, I'm going to take in 0.01 plus 0.05x squared. And I'm also going to change my window based on what this picture says. My vertical and my horizontal is my x, and it looks like it goes from 0 to 60. So 0 is my min, 60 is my max, and each one of these tick marks is 2. My min y is 0, my max is 150, and they're counting by tens. Okay, so here's the graph. And the table. I want to get the table as best I can. Starting at 0, it's going to be like that. I'll go up to 10. What's the value at 10? Actually, I can do that here. You might not realize that, but if I go to my graph and I go second calc value, I can start typing in some numbers and finding out their values right away. So at 10, it's about 5. Whoops. 20, it is 20. At 30, it's 45. So here's 45. At 40, it's 80. At 50, it's 125. So here's 125. And at 60, it is 180, which is off the charts. So the graph looks like this. Okay. Now the question said, Nancy wants to have the highest savings possible after a year. A year is 52 weeks. So that would be right here. 52 weeks, this is A and this is B. She chose B. Was she correct? And the answer would be yes, she is correct, because B is an exponential function and will increase faster. Actually, that's not completely true. It's a quadratic function. See the 2 up there? So I misspoke. That's not an exponential function. It is a quadratic function. Last question. 2014 winner of the Boston Marathon runs as many as 120 miles per week. During the last few weeks of his training for an event, his mileage can be modeled by M of W equals 120 times 0.90 to the W minus 1, where W represents the number of weeks since training began. Which statement is true about the model of M of W? The number of miles he runs will increase by 90. So the percentage that we're talking about is what's in here. And what's in the parentheses always starts as the model 1 plus or minus R. Now, if I started at 1 and I end up with 0.9, I had to actually subtract 10%. So it's not increasing by 90%, it's actually decreasing by 10%. So that's not true. The number of miles he runs will be 10% of. 10% of is more of what this is saying right here. That's actually saying 90% of. So it's not 10% of, it is 90% of. M of W represents the total mileage run in a given week. We'll come back to that. W represents the number of weeks left in his marathon. It says right here, W represents the number of weeks since training began. If I'm on the 5th week of training, my W would be 5. But if the marathon is still 20 weeks away, then that's what this is talking about. By process of elimination, it has to be choice 3, but again, here's why. M of W is the output. It says right here, during the last few weeks of his training, his mileage can be modeled. His mileage is this formula. So M of W represents the total mileage run in a given week. Since it's based on the value W, then we know that that's actually true. You plug in a certain number of weeks, you get an answer. That's how many miles he ran that week. Okay? And that is part 1 to January 2017. Good luck.